Welcome to the ADAS Empowered podcast. This is the show where collision repair professionals, calibration techs, insurers, and OEMs come together to stay ahead of the curve. Each episode, we'll dive into the latest in advanced driver assistance systems, exploring emerging technologies, calibration best practices, and evolving industry standards. Whether you're in the shop, in the field, or in the boardroom, this is the go-to source for thought leadership, collaboration, and real-world insights to drive safer and more efficient repairs. Let's get empowered together. All right, welcome everybody to the ADAS Empowered Community Podcast. My name is Joel Adcock. I'm the Director of Partnerships here at REV. We have today with us a special guest, Brunno Moretti. Bruno is the president of Essential Technologies and has been in and around the automotive and repair markets for many years, and we are excited to have him as part of the podcast today. Bruno, again, appreciate you being here. Appreciate you accepting our invitation to be part of this. This is really exciting for us. So, really quick, just a quick PSA on this podcast. This is where we want collision repair techs, estimators, shop owners, and managers to come hang out, sharpen their knowledge a little bit, stay ahead of the curve, talk about what really matters in the repair industry. And, our goal is to kind of cut through a lot of the noise with honest conversations and folks like Bruno who are really out in front of making sure cars get fixed correctly. So, as we like to say, whether you're turning wrenches or turning strategy into results, we think this podcast is for you. So, without further ado, let's get into it here. So, Bruno, go ahead and take a few minutes, introduce yourself. We'd love to hear a little bit about your background and kind of where you've come from, what
Yeah,
you're doing currently at Essential, and what they're responsible for. And we'll dive into some topics here.
you bet. Yeah. So yeah, thanks again for having me. I think it's a great mission, right? I think there's a lot of lacking information and other things that a podcast like this can help solve, right? So appreciate you guys putting that together and inviting me. So yeah, no. So look, I've been in the automotive industry, from out of college, right? So I went to school for electrical engineering, and I worked on, General Motors for about 10 years. Most of that time was working with ADAS, right? So very early on, when backup cameras just became a federal requirement, I worked on the surround view, the rear camera mirror. Then I really got into some ADAS with Super Cruise from camera development. So a lot of the ADAS. Then later, in my time at GM, I was working with the next generation of Super Cruise and also with the Cruise automation team, not to get confused, in San Francisco that was doing all of the robo taxis, and I was responsible for all of the hardware for the sensors, right? So cameras, radars, lidars, microphones, ultrasonics, right? So everything from a technical perspective. So I was part of the teams designing the architecture, part of the teams defining the technical requirements
Mhm.
of those sensors and what they had to see and how they had to react and all of that good stuff. Then I spent a couple of years at a company called ZF. They're a large tier one supplier for the automotive industry. Also responsible for making cameras, radars, a bunch of other things, including airbags and suspensions and a bunch of other things. I was responsible for the North American market there, and then the past 3 years, I was working at a company called Septon for lidars. So again, different sensor modality that's coming that uses lasers to create a 3D mapping of the world around the vehicle. And then for the past almost like 8 months now, I've been at Essential Tech. So I run their ADAS division, and with the focus of leveraging Essential's technology, which is a lot of people may know Essential as or previously known as Burke Porter.
Yep.
Burke Porter's been in the industry for 70 years, 70. I just want to make sure people understand.
7-0, yes.
And making all of the end of line equipment for OEMs. So all of the anything that's test and measurement, Burke Porter does. There's a bunch of other stuff too, but the main thing was all of these end of line equipment, which includes ADAS calibration at the end of line for the OEMs. So that we decided to leverage that technology into the aftermarket. Really look into the experience and pedigree the company had, at the end of the line, and then let's automate and use all of this information to go and create aftermarket solutions, right? So, and that's kind of, my role and kind of my history up to this point.
Love it. I appreciate it. It's fair to say you've got a lot of experience in like the development of the actual technology that's
Hmm.
on the cars today. I mean, which I think is fascinating. I think when you think about when we just put a small square on a vehicle and we consider it a radar, that there's not a lot of thought of like how that development actually goes into what's in that radar or what's in that camera. And I think we'll talk a little bit about like development stages of like how that technology kind of comes to life, what the life cycles are and things like that. And some of our early conversations on this, I was fascinated about it. So I want to certainly make sure we get some time into that. When you talk about like end of line for the OEMs, like with what Burke Porter's doing, talk a little bit about like what exactly does that mean? So we've got some clarity on that.
Yeah. So look, the vehicle gets assembled right at the assembly plant, and once it is done being assembled, there's a lot of things it needs to do. Right, wheel alignment. There is lots of tests that they run. Right, so that equipment starts. There's depending on the plant, right, but there are different stations the vehicle goes through. Right, first station, for example, in some plants, you go in and you have to do your alignment, and at the same time the vehicle, that machine that the vehicle is in, there's a roller where the vehicle wheels are spinning so you can actually get feedback. And then also in some areas, depending on the plant and on the OEM, they try to combine the ADAS calibration in the same station, right? As you know, OEMs are pumping vehicles, minute after minute, right? So the ability to do it super quick, what's called takt time, is extremely important, right? So then the vehicle, let's say they're done with their alignment and the calibration, then they go to what's called a DVT, dynamic vehicle tester. It's basically a treadmill the vehicle goes in, and we're able to get it up to 80 miles an hour. So it runs all of these other tests. You plug it into the vehicle right in both stations, and you're checking for emissions, you're checking for a bunch of different things. So all of that capital equipment that goes into these stations is what Borg Porter does, right? We also do dynos. We do, testing rigs for powertrain, for electric drives, and all of this stuff in the R&D side of things, right? So when
Mhm.
you think about the end of line, there's all of this equipment and software that goes into making, that last final checks before the vehicle is actually out to getting shipped. And then, of course, throughout development, there's a ton of areas where Workport is involved in, test and measurement for anything, right? You think about it, there's a rig out there that we're testing and helping things and noise and vibe and a bunch of different things. So that's kind of like the umbrella of a lot of the transportation part of our company. We also have aerospace and industrial, medical life sciences, and a bunch of other stuff. So we don't have time for that.
That's a whole other day of
Yeah.
conversation on something completely different and
Yeah.
certainly out of my strong suit to say the least. So that technology that's end of line that the OEMs are using, that's essentially the same technology that you guys have introduced at the aftermarket there, where shops are you make a relationship with a shop, and there's an opportunity for them to utilize that equipment to help with a calibration post-repair or during the repair, correct?
Yeah, the biggest thing, right? Because like we previously said, automation and speed are key at the end of line, right? So what we wanted to leverage the most is that experience with automating the process, reducing variance, and making sure that it's done the same exact way
Right,
every single time, right?
right.
You and I know that in the industry, there's a ton of different tools. All of the OEMs have different procedures. There's no standard, right? So, and then when you read some of these procedures from OEMs, right, it's saying plumb bobs and tape measures, and then you create a diagram, and then you try to find the exact placing of the target. And that's just not repeatable. That's not, you ask five different good techs, and they're going to do it five different ways. So what we try to do is just eliminate that, right? And say, look, our equipment is automated. You get the vehicle in it, it automatically places the target exactly where it needs to be because we have this huge database of all of the OEM calibrating procedures from, when ADAS started until now. And that gets translated into the system. The system then automates the locating of the targets. And then of course you plug in and calibrate, right? So it's really reducing that variance, which again, as we talk about quality of calibration and everything like that, not only the shops, but insurance companies and all of the other constituents want to make sure that these things are done correctly. And everything is documented from the very beginning to the end with precise data that shows, look, we followed it and it does meet the OEM requirements. And here's our liability proof, that shows all of the details that we actually went through. So it's a good thing for, the shop, the quality of the service, and then of course the end user that gets their vehicle back.
That's the most important piece of it, right? Is making sure we're putting people back in cars that are safe. And obviously,
Mhm.
if the OEMs are using this technology that you guys are using in the aftermarket at end of line, I mean, how much closer could you get, obviously, in
Right.
terms of meeting all of those check boxes? So that's fascinating. Appreciate you sharing that. And I would love to you've started your career, you said in this, post school and all that, and getting into sort of this field, which it's always interesting how people kind of land in the automotive space to some degree. But what were some of the early lessons that you learned as far as like looking at the technology that's put on systems? You talked about like the rear backup cameras. That was like what, 2018? That was that regulation that went into effect, I think. Don't quote me if the year's wrong, but I think
FMVSS 111, I think it
yeah,
was.
where anything produced in terms of a vehicle after that, it had to have a backup camera. I mean,
Mhm.
what were some of the early lessons that you learned? Like, what were some of the things that kept you kind of moving forward and motivated and kind of curbing that ambition, so to speak, as far as like what you saw?
Yeah, I think there's a very cool thing about working on something that actually translates into a larger goal, right? There's different jobs out there and that you can do with engineering and this massive industry, right? So, but very early on, I got involved with ADAS because I could say, look, I'm doing my job, but I'm also at the same time helping save lives, right? Like even with the backup camera example, right? There was the main reason why there was a regulation is because there were so many very unfortunate accidents where people are backing up and they don't see their kids, right? Or small animals or something. And that's just gut wrenching, right? Just to think about it, right? So the fact that I got to work on technology that would prevent those kinds of things really is what got me super engaged into this industry and kept me going further and further into, you know, how do we, go from just a backup camera, which is a passive way of doing things, to go into something that's active, right? Which is ADAS. And that's kind of been the driving, force behind me kind of sticking around with this, industry and really enjoying what I do. So I get to marry the fact that yeah, we're companies and we're trying to make money, but we're also doing things that are good for society, right? Like we're not just chasing money. We actually are doing things that will make it better for people in the streets and safer in the streets. So that was one of the things. And then you asked about learnings, right? The one cool thing about it is that once you're part of a large multinational organization like a GM or ZF, it is incredible to see just a number of smart people and the rigorous process that these technologies have to go through in order to meet the requirements for automotive, right? Automotive is one of the toughest. Consumer electronics, you don't have to have it work from minus 40 degrees to plus 85 Fahrenheit, right? You don't. Uh, Automotive does because everybody's expecting their vehicles to, you hit the button or you turn the key, it turns on. There was times that we were in cold chamber testing and it's minus 40, like it's really cool that, to see that the resiliency and the amount of work that goes into making a vehicle and the time, right? When you look at it, how long a development cycle takes for a vehicle, it is, I mean, it's more than 5 years, right? From very beginning to the ideation of the vehicle, to then getting first cut of metal, to then going into the validation cycle, and then to go into the plant, right? There's just so many steps, and I was always in awe that everything worked at the end, right? Like, because
Right?
it's a gazillion moving
Like a miracle.
parts. Yeah, right? It's a gazillion moving parts, and there are hundreds of, tens of thousands of people working in a single project, and from somebody that owns the visor, that somebody that owns the ADAS sensor, somebody that owns the whole vehicle, right? Like it's just so many competing opinions, priorities, and whatever. And then somehow at the end, it comes out and it's a very nice, fully functional vehicle. So for me, that was always like one of the big learnings is like, man, it takes a massive industry of people like just to get a vehicle out, the door, like from beginning to end.
Yeah. That's fascinating. I am, I'm always challenged by the technology that goes into a car, and you think of like vehicles of yesteryear with sheet metal, and you open up the hood, and it was pretty basic, right? You saw the engine and some of the other components, and it's just evolved. Now you lift up a hood, and it's completely different. everything has a purpose above and beyond what I think we're able to really understand about it. And then we get into like the actual technology that's sophisticatedly put on the car in certain parts of it that the sensors talk to each other, the modules talk to each other. And if there's some sort of disruption, then things may not necessarily work correctly. And I think that's, the thing that like you and I share amongst like many others as well is like making sure that it's not just a grab at, life in terms of revenue or things like that, but it's a shared purpose of having that understanding,
Mhm.
making sure that we have an emotional connection to the work that we're actually doing because it's really important because it really touches everybody that we know. I mean, even if you don't drive a car, you may be in a vehicle that, God forbid, like sensors aren't working or something's not working correctly. So it's incredibly imperative that we all have a stake in this. And I think that's like the overarching part of these conversations that we want to make sure we announce that it's really important. And again, I think you and I, speaking last week at the ADAS Symposium in Detroit at SEMA Garage, I mean, that certainly was evident. So, and I'd love to talk a little bit about that. So, being able to hang out with you last week was phenomenal. I don't know exactly when this will be published. So, for the audience that's listening to this post recording, last week was the initial kickoff from SEMA Garage in Detroit.
And Mima.
And MEMA, yes, yes, MEMA as it was called, which again, I don't think that's
Shmima.
trademark. So, apologies to anybody out there listening and not understanding what that is. Group of folks got together. Like there was what 60, 65 of us in a room, all varying different types of experience and parts of the industry from really from the aftermarket side, from repair to modification, were represented really well in that room. And again, facilitated by somebody that's got a lot of experience. And Jim Fish was a phenomenal facilitator, obviously with his professorship background at the University of Michigan and some of the other folks that were part of coordinating all of this. I mean, I think it was a top-notch event. And I'll be really curious to see like what materializes out of those conversations and some of the workshops and things that we did. What was your take on it? Like what did you come back with and like, car ride home and thinking of it sort of like late last week, what were your kind of your takeaways and what were you excited about from.
Yeah, no, I agree with everything you said, right? I think it was a well done event by SEMA and Mima with the goal of trying to understand, what can we do as an industry in the aftermarket to put our hands around the problem, right? Of ADAS, when you have it in the vehicle, it's great. There's a lot of studies and data out there to show that it helps reduce accidents. But when something does happen and you have to recalibrate it, or like you said in the upfitters, they are modifying the vehicle and they're not sure if the ADAS is working right. So that was kind of the premise. And having so many people from different backgrounds, but all leaders in the industry was very, to me, what was clear is everybody knew we needed to do something,
Yes.
right? Everybody had pain stories, horror stories of, oh man, I had this one thing that happened with ADAS, or I had this problem with this vehicle, or, you know, all of those were things that everybody had in common that they knew that there is a gap there that needs to be filled, and then how do we go about it? And that's what Jim,
Yep.
helped facilitate, is the ideation of not only what the problems are. And so we did a lot of ideation and try to truly define the problem and quantify the problem, and then of course what kinds of solutions we can put in place, and with organizations like SEMA and MEMA can help leverage their size and their influence to create something, or a campaign or
Yep.
legislation language or something
Yep.
that helps us put that together. So that was like it was really cool to be a part of that, right? What I also noticed, and it was kind of apparent, and you and I briefly chatted about that, is that most of the companies there and the representatives, you see that the aftermarket industry is just not yet using and leveraging technology, right, to do things a better and faster and safer way. It's still a lot of manual, and there's some things that are always going to be right, but there's just so many opportunities that I walked away and saying, "Wow, there is just this industry is ripe for." I'm going to say it, but like ripe for this, disruption. I know a lot of people overuse that, but it is a
True.
very manual, laborious, industry that people have been doing things the same way for a very long time. So to see that was also for me, it sparked a big light bulb saying, wow, there's a huge opportunity here for us to help automate and use and leverage technology to make safer decisions. Things like what Rev does, right? Using AI and other, technology to tell shops, hey, you have to do these calibrations. That's huge, right? Nobody was really doing that. There's a few companies, right? But I don't think anybody has had the impact that you guys had. And just that's one little aspect of it, right? When you think about the whole life cycle of that, and just how technology can be so helpful. And I think that's why you guys have had such a good traction, because it's a easy to use product. It tells you exactly what you need to do, and so I think the industry is yearning for this kind of technology addition.
Yeah, I think disruption's a fair word. I mean, in all honesty, what I came back with, and I had a relatively short plane ride home, but I mean, I was spent from the workshops that we did in the groups, and there was a lot of thought, and it really challenged you to think about, like you say, it was ideation of problems, really narrowing those problems down because you could list 1,000 problems, and then that's obviously, all right, well, let's work together to create some sort of resolution and solution to these things. And a lot of the, I think, final answers that came from like the 6 or 7 groups that were workshopping together, a lot of those solutions were disruptive or would be
Mhm.
disruptive. And
Yeah.
depending on which direction those things go, based on decisions made by SEMA and MEMA working together, if there's 1 or 2 or 3 that they ultimately act on, I have a fair belief that those will be disruptive. They will take time, they will take a lot of effort, they will take a lot of volunteer people power and things like that, but they ultimately will be disruptive. I think ADAS has been disruptive. The gap that we're feeling right now is this, where are we at? What do we need to do? How much efficiencies do we need to gain? And how manually currently is the whole process? And you talk about like the manual process of like plumb bobs and tape measures and tape on the floor, and that's gotten us to a certain level of, all right, we need to continue to modify efficiencies to not just improve our level of service, but just a better experience overall, and both internally at the shop for the aftermarket folks and obviously for the consumers themselves too. So man, I'm right on with you there as far as like sort of my takeaways too. So you gave a presentation. You were able to get up in front of the group, and a very unbelievably candid opportunity, I think, to get a lot of eyeballs on what you presented. Take a few minutes, walk us through what you did and sort of the hypothesis, and what your presentation was about, I guess.
Yeah. So one of the things that, as soon as I joined, the Burke Porter, and what I wanted to do is, I kept getting told, I'm like, well, we have to follow OEM procedure. I get why, right? And an OEM procedure, is the best. Okay. Well, and there's people doing poor calibrations and using, bad equipment or bad, methods. I was like, okay. And how much better is a proper OEM calibration versus a poor one? Well, I don't know. Well, nobody knew the answer, right? So, in my mind, coming from a background of engineering, right, you need to quantify what the issue is, right, to truly see what we're dealing with. And nobody had done that. We looked and looked for any kind of test. There's always been little studies here and there of hypotheticals, right?
Yes.
Yeah, that what could happen. And I was like, okay, well, we need to go and uncover that rock, right? And basically, what I wanted to do, what we did, was we got a new vehicle. We tested all of the NHTSA approved, tests for AEB, for pedestrian AEB, for adaptive cruise control, lane keep assist or lane keep, the lane alert, departure warning, and run it with the baseline vehicle, run it with a vehicle that had no calibration, which is mimicking a vehicle that had some repair that kind of modified the location of the camera or the radar, or things that we anecdotally saw in the field several times, right? And then a poor calibration, which is again doing it outside, no flat floors, not following the OEM procedure, not checking tires, not filling the gas tank, or in some cases, and then a proper good calibration, which we used our equipment in a very controlled environment with flat floors and diffuse lighting and all of that, right? So that was the goal, was to measure the discrepancy between those different methods, or how to do calibrations. And the presentation then goes through and walk through the actual results. And we actually have a white paper coming out with those results. So hopefully soon we'll be able to share that with the team. But basically, right, the findings, the hypothesis before going into it was like, okay, the baseline will perform great. The the no calibration is going to fail most of its tests, if
Hmm.
not all of them.
Hmm.
The poor calibration is going to have erratic, big variance kind of behavior, and then the good calibration is going to match the baseline. But when we actually did the test, right? Because look, I took a risk by doing this because I could have uncovered that a poor calibration, a good calibration are the same, or I could have
Right.
covered that
Right.
it does worse or something, right? But I
Yep.
said I need to uncover this because otherwise I feel like I'd be selling a lie, right? Like I need to quantify it. So yeah, the results show that the good calibration perform better than the poor. The poor calibration had more erratic behavior, larger variance. So in AEB events, it would stop super early or stop super late. So big variance in those numbers. The good calibration was tightly controlled, right? You knew what to expect every time. And the no calibration smashed through the target every single time. I mean, it didn't even blink at it and didn't even engage the brakes or anything like that. It just, plowed right through targets, right? So again, that confirmed a lot of the hypothesis. Now, there were some surprises, right? And the biggest one to me was that, the vehicle that we used was a 2024 vehicle with 13,000 miles. So not old, not many miles on it, and, we double check and there
And no
wasn't
prior
any
damage on this
no
car, right? I
prior
mean, it was.
damage, right?
Yep. Right.
And, that performed worse than the poor calibration and even worse than the good calibration. So that was a big eye opener to us that, and Joel, keep in mind, right? This is one vehicle, several tests, right? So it's a small data set, but again, somebody had to start. And that's what we were trying to do is to get it starting, understanding what's happening and having data to back it up, right? So I don't want people to think this is a vast study with hundreds of cars. No, it was one car, but we did run it several times with several different, types of calibrations, right? But yeah, the baseline, for example, in the pedestrian AB, it, hit the target or the pedestrian 4 out of the 7 times. And then the poor and the good calibration. The poor calibration did not hit it, but it also got extremely close. And again, variance. And then the good calibration have very standard no hits and also within always the same stopping distance, right? So it was very interesting to know that a regular wear and tear of 13,000 miles in this specific vehicle was enough to throw off the ADAS system, that it needed a calibration, right? And it brings up this whole good calibrations be part of maintenance, right?
Yep.
So
Yep.
it was very eye opening.
Yep. For sure. Yeah. I think, I've been a part of presentations in the past, and the conversation or the questions come up like, hey, we live in the Midwest. It's full of potholes, rough roads. If you buy a vehicle and the end of line calibration still exists, but you drive at a certain distance and miles and time and things like that, does ultimately that stuff start to shift and move a little bit? One vehicle, obviously, like you say, it's a small sample size, but the proof in that one vehicle shows that 13,000 miles in, there is some variance there. There is some potential for exactly, for some concern, for lack of a better way of saying it. It's fascinating, and again, remind me who you did the study with. It was a group out of Ohio, correct?
Yeah, it was the Transportation Research Center. So
That
they're,
TRC, right, right,
the
yeah,
TRC, NHTSA, uses them for a lot of their testing. Honda kind of co-owns it. It's a weird like situation where they own the land, but it's something. But Honda does a bunch of their testing there from Marysville, right? Because they're right there.
yeah,
And then all their OEMs use it as a good testing track. So they're like extremely science based. I mean, you look at the vehicle, the whole back seat was instrumentation to measure the inertia, to measure little microphones to hear when the beep went with millisecond accuracy. The dummy vehicles and dummy pedestrian, they all have sensors, and we know exactly what the distance is between the vehicle we were driving and the dummy. So they're able to really give you, centimeter, level of accuracy when knowing what the stopping distances was, when the alert came, and all of that. So they do an excellent job of giving you true data that is reliable, that you can start making some decisions based on that. But again, we need to, as an industry, run many more studies, right?
Yeah.
With sample size of lots of vehicles to really start understanding what that looks like, right? What is the size of this problem, right? I uncovered one little pebble, but if we keep flipping rocks, we're gonna find either bigger issues or we're gonna find things that are performing more according to what we think, right? So, and then gathering all of the information, normalizing it, and getting what the average is to truly quantify what this problem is. But it was just the first step. And, I'm excited that we did it. I think the response at the symposium, people were, kind of blown away the fact that somebody was actually going after and doing this and trying to quantify this. So I think it was extremely important for us to do it. And I'm glad that we did.
ADAS isn't the future, it's already here. And if your shop isn't calibrated to handle calibrations, you're falling behind. Rev empowers shops to catch every required calibration, generate OEM compliant documentation, and recover revenue that used to slip through the cracks. Trusted by top performing shops across the country, Rev is the new standard. Don't wait. Schedule your demo now at revhq.com.
Do you have any aspirations to do additional testing on different vehicles at some point down the
Yeah,
future?
it costs a lot of money.
Nothing's cheap.
No, no, no. It is not cheap. Because they do good work, they can charge a decent price, right? But no, because of the end of line stuff that we do, right, as Berg Porter, we have technology that those rollers that I told you about, the
Yep.
DVT, right? Those are, the vehicle is stationary in a location, but we have a prototype that we've been using and working with different companies that we are actually able to place the vehicle in this DVT, and we have a scene generator for the camera, and we have a radar target emulator that we can then induce the vehicle to engage the ADAS. So we will perform a lot more tests. It's going to be in this controlled and cheaper environment for us, right? But now with this technology, we have the chance to verify the ADAS performance of several different vehicles with statistically significant numbers. And then, maybe a year from now, next time we talk, right, on a podcast or something, I can show you those results. But we are definitely engaged in starting that process of continuing the tests. So again, we can help quantify the size of the problem.
I have to believe there'd be other people that might be interested in like being part of this or, some sort of relationship or partnership. Cause I think there's a lot of folks that are highly interested in vehicle safety.
Uh-huh.
This sample size, I think if they saw the presentation and the white paper when it gets released, it will open up some eyeballs as far as the hypothesis, the baseline, considering the short amount of time this particular vehicle was driven, but then obviously the results in some regards where specifically with no calibration, the results are terrible, right? I mean, that's
Uh-huh.
the thing that I think concerns me the most is, all right, let's say you're doing calibrations in an uncontrolled environment and you're at least doing something, right? You're at least trying to validate within some level of measure that things are working as they should. Whereas if you're not doing any calibrations, which we know there's still a huge gap of number of cars that need something that aren't getting it, this should be that sort of that olive leaf of like, hey, this is the wake up call. This is the thing that you really need to pay attention to. And this is the thing that shop owners think about in terms of liability and safety. And it's only going to continue to perpetuate. So I don't want to be a Debbie Downer on this by any stretch, but I really wanted to talk about it. I didn't have it on our radar to chat about, but then when you did the presentation, like I'm like, we've got to talk about this.
No, but I
So
think, you said you don't want to be a Debbie Downer, right? But I think we have to sound the alarm.
yeah,
And every time either I have a keynote or something, I always bring this stuff up. And I said, I hope you guys are scared because
yeah,
it's scary out there, right?
it is.
There's just a lot of potential concern and, there hasn't been this landmark lawsuit, but one is coming, right? Somebody's not going to calibrate. Somebody is either going to calibrate poorly, and there's going to be an accident, and there's going to be a massive lawsuit, right? So we're just, waiting for that to not just waiting to happen, but we know it's going to happen, and we're just trying to anticipate that so it doesn't have to happen, right? So I'm okay being a Debbie Downer, right? Because
The
it's a
voice of reason,
yeah, well, we're trying to like
or at least two.
sound
Yeah,
this alarm, and the more we peel the onion and the more we see that there's just not that, there's no government, guidance, there's no government legislation or regulation that says anything about, calibration, right? So shops and companies are free to do what they want, and the insurance companies, are involved, but you know if they're paying for it, they're kind of off the hook, right, on a liability perspective. So it really lands on the shop owners to truly stand what the liability concerns are of not doing it. Of course, big one there, right? Missing it, and then just, could be called negligence, and then doing it incorrectly or farming it out to a shop that does it incorrectly, and then have it coming back to bite you, right? So that's all things that, you can say it's a Debbie Downer. It's like, man, guys, you need to pay attention to this because it's not going away. ADAS is, I think something like 30 to 40% of vehicles on the road today, which is a, 12.5 or 12.6 years average age of a vehicle on the road. And then that 90% of new vehicles have some level of ADAS, right? And that in 2029, there's the new, federal regulation FMVSS 127
Yes.
that's going to require AB to be, 100% penetration in every vehicle, right? So the problem is only going to get bigger, and nobody has been sounding the alarm. And I think, podcasts like this are a way for us to get the information out to people and say, you need to be paying attention to this.
Yep. I agree. I totally agree. And that kind of like moves us into that next thing that I wanted to chat a little bit about is that regulation coming down in 4 years. Um, we had regulation back in like so 2018 with rear backup cameras, and I think for myself noted it's a huge safety thing, right? Being able to visually see kind of behind the vehicle, and AEB, automatic emergency braking, the regulation coming down, MV
FMVSS 127.
127 will mandate that every vehicle produced at that point going forward will have automatic emergency braking, which will help with certain ADAS functionality that's obviously going to uh, allow the vehicle for momentarily take over if it determines that there may be some sort of sudden impact in front of the car. Talk a little bit more about that. Like, what do you think is it good for regulation, or is it good for the industry to have this? Is it, I mean, I think for consumer and society, it certainly is. There's benefit, right? I think anytime there's additional safety measures taken, it's benefit. You go back to like the 70s when the braking, not the disc braking, but I'm losing my train of
Drum,
thought. What's that?
the drum braking, or what are you talking about?
Well, when we went from the disc brakes to
ABS?
ABS, yes,
Yeah,
my
yeah.
goodness, I couldn't think of it. ABS, and that was a huge thing. And then I heard it mentioned that traction control may be the greatest safety feature of all time, quite frankly. And I'd love to get your thoughts on like, all right, number one, regulation, but number two, on this particular regulation, like, what are your thoughts as far as is this good? Is this bad? Does this continue to drive the narrative of like not going away, like you mentioned?
Yeah. Well, it definitely is not going away, and it's only getting more prime time, right? As far as ADAS is here to stay, and it's going to be in every vehicle, right? Eventually, it's just going to be a fact. Starting with the FMVSS 127, right? This is, uh, personally, I think it's a good thing, right? Because when you look at what's in in the market today, ADAS is a feature. ADAS is not considered safety, by the OEMs, and yes, it helps with it, blah blah blah. But whenever you make it an option, right? Think about an OEM making an airbag optional today. Everybody would scoff at that, right? That's what's going to happen with with ADAS, right? ADAS is going to become that standard that's going to be associated with safety, not with the feature, right? Safety is not a feature, right? It should be standard. That that regulation does that. It makes the OEMs put that technology into the vehicles. When you look at today's technologies, right? There was a study from AAA in 2024 that showed the effectiveness of AEB in vehicles that were in 2018 versus 2024.
And you did a podcast on that yourself
I
too,
do.
correct? You
Yeah,
did, yeah, yeah.
it's not a podcast like this. It's an AI podcast. It's called ADAS Garage, but I use AI technology to dissect a topic. So, for example, one of the episodes was this AAA study, and it's just a quick, easy way, 15-minute way for you to consume information, right? Rather than sitting down and reading hundreds of pages of a PDF, right? So for me, that's what I started the podcast, and actually is, people like it. We're in over 22 countries now. So
Awesome, man. I love to hear it.
yeah,
Great.
so it's again, I think people are seeking to understand, and that's what it kind of hit that nerve with people, and it's been mildly successful, I'd call it, right? So it's not like a hit. I'm not quitting my job anytime soon, right? But that study says that the 2024 vehicles perform much better than the 2018 vehicles. Now, with a big caveat, the caveat was that it works very well from 0 to 35 miles an hour, right? Anything above 35, it drops dramatically, right? And anything above 45, it's almost not working. With that in mind, you look at FMVSS 127, and I don't know exactly the number, the speed. The AEB has to work at higher speed, something like 62 miles an hour.
I think,
I
yeah, I
could be
heard
wrong. Don't quote
62 or
me.
64, something like
Yeah.
that. It rings, yeah,
But higher.
right.
And it also has to work for pedestrians, right? Not only for vehicles, and it has to work at night. That's a big difference
Big, big
maker, right?
difference.
Because
Yeah.
there was also lots of data from NHTSA showing that pedestrian deaths are the only one that kept growing over the years versus others, right? So that shows that ADAS systems today are not good at detecting pedestrians, especially at night. And that's because your camera doesn't see very well at night, just like your eyes, and because a pedestrian has a very small radar cross section. It's called RCS, and it has a trouble detecting that. So even at night, when the camera can't see well, and the radar it has a hard time with a smaller target that's not metal, it struggles with it. So you saw this is something that the government focused on. It's like we got to make pedestrians and the higher speed vehicles being able to for the ADAS to stop from collisions and to be able to perform at night, right? So that from a safety perspective is fantastic, right? So, you know, I have kids, they're running on streets, right? And doing all of the things that kids do. To know that we have technology that's coming that's going to help prevent any kind of accidents like that, for me, it's a win. It does also introduce more complex technology. It introduces higher resolution cameras, imaging radars, which, are 4 times more powerful than the current radars. And so you are now introducing more powerful sensors, and some vehicles could choose lidar to do it as well, right? Because it's active lighting and it will see it at night and see small pedestrians. You're going to see a mix of the OEM is not telling them how to do it. So each OEM is going to figure out a solution. So again, we go back to that discussion of standardization. There is not going to be a standardization on the sensor set. It's going to be a standardization on the results. So then you're going to have OEMs using more cameras, radars, lidars, combination of all three. So that is going to introduce a lot of confusion and concern to the aftermarket and service industry.
All the more reason why we need to get out further ahead of this now versus
Mhm.
waiting until it's on our doorstep, which it's rapidly approaching, to say the least. So fascinating. I think some of the technology, like in the cameras, like you mentioned at night, and I've read some of this a little bit too, like the technology on the camera on your cell phone may be of better quality. I could be wrong. This is what I feel like I've read. The better quality versus what's potentially in some vehicles now, only because of the age of the camera or the sophistication of, like, what was available at that time, 3, 4 years old, like some of those vehicles that are 2018, 2019, 2020 now. So let's talk about, like, how does an OEM, what's that life cycle like to get from concept to it's now in the vehicle and it's activated, it's live, it's how long does that take?
I think it's a long time. It does. But, to your first part of the question, which is like, the quality, right, is better. Yeah, like the number of megapixels, uh, in a
Megapixels, yeah, I couldn't think of the word, yeah.
in the cell phone camera is much, much higher than what's in the vehicle. And there's a reason for that, right? Because of your question of how long does a development take. So you got to throw back a backwards pass 4 years ago is what is on the roads right now, right? So 4 years ago, you had whatever technology available, but then you can say, well, 4 years ago, my camera on the iPhone was already pretty good, right? That's right. Because to our previous point of consumer electronics don't have to go through the same rigorous testing of -40 to +85 Fahrenheit, you just don't have as many suppliers that are spending tons of money to create these components. So an imager on a camera, right? The imager on the camera of your iPhone is top notch because it doesn't have to go through these massive tests. And consumer, you're selling gazillion iPhones versus vehicles. Yes, it's still in the millions, right, for vehicles, but it's not nearly as big as what, a consumer industry is. So the supply base is constrained, and you have to go through this test, and you have to have somebody willing to spend the money and the time to create something. So yeah, the technology is always lagging because there is just that much more that you have to do. And by the way, the -40 to 85 is for the vehicle, which if the vehicle is sitting on the sun, the internals of something is much more. So those tier two, tier three suppliers, they actually have to make it work at 120 degrees Fahrenheit, right? So it's extremely hot, environment that these have to work. So yeah, there is just a lot of work that goes into that. So you see a little bit of a lag. As far as the development cycle, yeah, it takes, the suppliers themselves, a lot of times they start development because they think, yeah, there's going to be a need for this more powerful radar, right? So that takes, just to get some proofs of concept, 2 years, right? Then, something working because there's just so much engineering on, for example, the antenna of the radar and all of the testing they have to do in the chambers. And then the mimic chips, which are what actually produces the radio waves, you know, that's system on a chip. And then there's just a lot of work that you have to do to produce the chips and a lot of investment, right? Then the OEMs are like, hey, I want to put this in a vehicle 4 years from now, right? Because they usually source 4, 5, sometimes 3, depends on the OEM, right? Ahead of a release of a vehicle. Then those suppliers will say, here's what I have. It's at a certain level, right? There's A samples, B samples, C samples, and then production, right? D samples is what was, it passed, design validation, it passed process validation. Those are standard automotive terms, right? That if somebody's listening, they know. But if you don't know, these are standard tests that you have to pass. A lot of these tests are 16 weeks, right? And then if you fail it, a certain leg of it, you have to redo it, right? So, then they engage the OEMs engage the suppliers, then they go through this development from B sample all the way to D sample as the vehicle is also progressing into their, lifetime and then or life cycle. And then finally, right, once it's getting to production, it was 5 to 7 years before when the actual technology was first developed on a prototype
That's
stage.
crazy. And these suppliers, I mean, they're held to, is it ISO standards or SAE standards, or what typically, or what level of sophistication of standard are they held to make sure their manufacturing processes, their operational standards or things are held
Yeah.
in check and
Specifically to ADAS, right, there's something called ASIL, which is Automotive
ASO,
Safety
right?
Integrity Level, right? And then they measure the lowest level is QM, which is quality management or something like that. And then go ASIL A, ASIL B, ASIL C, ASIL D, right? It will depend. It's not like they are following an ISO that they say, I need to make this whatever, right? Some OEMs, depending on the safety case, they will say, I need my radars to be ASIL B, which is there's a certain level of self-diagnosis that has to happen, like a watchdog inside of itself that needs to be able to tell the vehicle, the computer on the vehicle, that something is not going right. Please don't engage, like sets a flag up and says, something wrong with me. Right. So then there's like, a QM, which is again almost nothing, right? There's just no real requirement. So depending on the OEM and depending on the safety case, they then leverage that requirement on the supplier to say, I need this radar or this camera to be an ASIL B component. Now, when you do that, it adds money, right? Because I'm adding sensors, I'm adding temperature sensors, I'm adding watchdogs, I'm adding software, I'm adding all sorts of things to those components that are going to be able to detect if something is wrong,
Hmm.
right?
Hmm.
And then there's the highest level is ASIL D, which is almost like a, you know, I know everything that's going on with myself, I can report things, I have some level of redundancy that helps me, if something breaks, I can fall back into something, right? A lot of times you see the safety case being that a system has to be ASIL D, right? Meaning my ADAS system is ASIL D because I have a camera, I have a radar, and I have a LiDAR. And if one of those ASIL B, as in boy, fails, I can still drive the vehicle with the other two sensor modalities, right? So stuff like this, it is again, there's ISO 26262, which is functional safety standard that that's how you basically say, yeah, I prove that I am ASO whatever.
Hmm.
But again, there's not there's not a requirement that an OEM has to be everything that they do has to be a certain ASO or it has to be meet that whatever, right? So there again, there's very little regulation that is telling the OEMs how this has to run. And then it comes down to decisions by each OEM, and then each OEM may have conflicting priorities on cost versus other things. So you're going to have varying levels of performance and safety case depending on the OEM.
Fascinating. Let's shift gears here a little bit. Uh, like this is just phenomenal. Like your level of knowledge and depth. It's just to reiterate, kind of like what you mentioned. Let's definitely get back on another chat, another podcast at some points. Thinking about the future, we talk about like the regulation coming out in a couple of years. I've got a couple of kind of final questions I want to kind of pose to you here, and you can kind of answer them collectively together. Where do you think, where does Bruno think we're headed in the next 3 to 5 years? And if you had 5 minutes to spend with a shop owner or 5 minutes to spend with a technician, what advice would you give them?
All right. To the first question, next 3 to 5 years, I see a lot of confusion and chaos because, again, I think we know the state of the industry today. There's already confusion and it's only going to grow, right? But I also see a lot of positives where, like the symposium with SEMA and MEMA, there are active efforts in trying to mitigate or help eliminate some of the confusion and education, right? So I think, you know, I'm both hopeful and a little concerned, right? Because again, there's just so many different body shops and insurance companies and constituents and stakeholders that are just not aware or not as well informed on the things that are going on, right? And we didn't even touch on the vehicles that are coming, which you asked me 3 to 5 years.
Yeah.
Yeah, there's vehicles coming out in 2026, 2027 that will have 5 cameras, 6 radars, 1 lidar, right? That's happening. That is in their roadmaps, and VW announced it with Mobileye and Valeo that they're
Yep.
doing it,
Saw
right?
that.
So
Yep. Yep.
that is gonna grow, and that's gonna you know, if we're not prepared, the industry is gonna suffer, right? With being able to comply with the requirements, being able to, calibrate systems, being able to detect if they need to be calibrated, all that kind of stuff, right? So look, I spend a lot of time with shop owners and estimators and technicians, right? But one of the things is always get informed, right? And I think that was one of the original reasons why I created the ADAS Garage podcast is because I wanted to create an easy way for people to understand the technology, understand the impacts, understand implications of what calibration is. And I haven't really even gotten too much into calibration, to be honest, because I wanted to start the podcast with what is ADAS? What does it do? How are people seeing it? How is it performing? What do insurance companies see? What are the benefits, right? So all of those are things that I wanted to focus on in later episodes, right? We're gonna address more of that calibration side of things, but I wanted to make it an educational podcast to really help people. So in talking to man, I'm
You're good.
coughing over here.
Yeah, you're
Well,
good.
we know it's real. It's not AI. But it's really just take the time to educate the people in the shop, take the time to understand the impacts of not doing things properly, right? And, for their own well-being, right? For liability, United States is very litigious. So something happens and it's on your hands, right? You're the last one to touch the vehicle. So be extremely careful with that. So it's all about education at this point. It's really getting the word out.
Yeah, I completely agree. I think it's more of like the shift in thought now with, obviously there's a certain age of vehicle that's on the road, like it's 12 and a half years, and we fast forward 5, 6 years, and if that's still the sort of the same age range of like vehicles on the road, well, now it's not 2012s on the road, it's 2017s, 2018s, 2019s, which certainly that level of number of vehicles that have got ADAS on the road has increased at the same rate, and it's now more of you should be checking boxes on why you're not calibrating something on that car. It's not finding what you need to calibrate or finding what you need to do in terms of a steering angle reset or a functional operation that's tied to safety. It should be like, all right, I'm not coming up with anything from researching OEM procedures or platform like a Rev or whatever you're using, and I'm trying to validate that it's telling me I don't need to do anything. Is this actually correct? And now it's like, all right, it's not finding what you need to do. It's finding out like if there is nothing to do, right? Because it is just maybe a simple bumper job or something simple. It's not triggering a calibration. I think that's the narrative and that's the shift. And like where as a shop owner, I would start thinking about like, all right, I've got a car here that I can't find anything that I need to calibrate in and I've reached 2, 3 different things, my redundancies. I've put things in place here in terms of how we look at these things. And I think you probably share sort of that same sentiment too. Even now, let's
Hmm.
not wait a couple of years to get to that point, but we got to really start shifting that narrative.
Agreed.
Man, I really appreciate this. I will let you
This
go.
is awesome. Yeah.
Yeah, no, this has been great. I feel like we could jabber on about this pretty much all day long. Maybe next time we can do this on the golf course and
There you go. Yeah.
we'll get a GoPro to follow us around for a day or something like that. Make it really interesting. But
Yeah. I love that idea.
Bruno, appreciate it. Love what you're doing, man. Really just
Appreciate it.
keep fighting the fight. Obviously, if there's anything we can do, please let us know. But we appreciate your time and appreciate everybody chiming in today and taking a listen, everything like that. So good luck to everybody. If you have any questions, reach out to Bruno at Essential Technologies. He's on LinkedIn, not hard to find. Again, Joel with Rev. We appreciate everybody, and we'll let you all go. Thank
All
you.
right. Thanks, Joe.
You bet.
You know, I was talking to Jim from ADAS of Texas the other day, and he said something that really stuck with me. He told me he used to spend 30 minutes to an hour researching repair procedures, just trying to make sure he wasn't missing anything the vehicle actually needed. Then he started using Rev, and that time went down to nearly zero. Think about that, an hour of research down to instant results. If you're in collision repair or ADAS calibration and you're still doing things the hard way, it might be worth checking out Rev at revhq.com. That's REVVHQ.com to see what Jim's talking about.